Hey y'all, today we are going to look at graphing exponential functions. Just want to remind you that I already have all this stuff written down, so if I start going too fast, please remember to just pause, give yourself a chance to get caught up if you are taking the notes like a good math student. If you are just sitting and staring and watching me do the work, okay, just don't be surprised if you have trouble with it and you need to go back and reference it later, okay? Alright, so today we are going to be looking at the exponential function. So the parent function for exponential is f of x, that's our function, equals b to the x power. B is our base, so that's going to be some number, and our variable is going to be the exponent now, which is what makes it exponential. Okay, so something raised to the x power. That is the exponential parent function. Okay, if b is greater than 1, so we have a number here that's 2 or 1.5 or 7, the function is going to be called an exponential growth. Exponential growth, because the number is bigger than 1, and our line is going to be forever increasing. So it's going to start low and it's going to always be getting higher and bigger. Okay? If our number is less than 1, our base value is less than 1, then the function is called an exponential decay, meaning it starts high and it forever decreases from there. Forever decreasing. Okay? So that's the basic parent function, and then we are going to talk here in just a little bit how we do transformations with those as well and how we shift them around. Okay, so our exponential function is going to have an asymptote. Okay, remember an asymptote is a line which our graph gets close to but never crosses. Okay. And just a side note, in our exponential functions, our asymptotes will always be, they will always be a horizontal asymptote. For exponential, we will always have a horizontal, okay, going this direction through y equals something, okay? All right, so I have a couple graphs to look at, and then we're going to talk about the transformations. So I am going to pull up Desmos calculator on my phone. So I just went to Desmos calculator and it pulls this up. Okay, so I am going to type in my function 2 to the x power right here in our line. So 2. This thing right here that says a to the b power, that's our exponent, 2 to the x power, and I hit enter, and it gives me a picture of my graph, which I can slide around like this. Okay, so I'm going to sketch this. Before I do that, do you see this little, the little cog right here, the little settings thing? When you click on that, it gives you an option to look at the table. So this thing right here is our table. If you push that, it shows me some numbers here for this graph, which you can't see here, but they are listed there. Oh, can you see it? It starts to wig out. All right, so I'm going to just jot down a couple of them. I'm going to write -2, 0.25, -1, 0.5, 0, 1, 1, 2, and 2, 4. Okay, so what this means is, remember, these are our x's, these are our y's. So if I put in a 0 for this exponent, 2 to the 0 power, anything to the 0 power is 1. So that's going to be our 0, 1, that's our y-intercept. Okay, if I put a 1 there, 2 to the first power is 2, so 1, 2 will be a second kind of key point. If I put a 2 right there, 2 to the second power is 4. Okay, and then as I come back this direction, my line is going to get closer and closer to 0. -1 is at a half, -2 is at a quarter, and it's going to keep getting closer and closer to that line, but it's never actually going to touch it. And the way that, I don't know if y'all can see this, if I type a number instead of, sorry, it starts to wig out. I don't know that I can make this any bigger. No, sorry. So if I put in like a -2 to the -5th power, okay, that's still not a negative number. It's going to be getting closer and closer to 0, and it's going to kind of ride along this x-axis here. It'll get closer and closer, but it's never actually going to touch it. Okay, so remember we said that if b is bigger than 1, this is our b value, 2 is bigger than 1, this is going to be an exponential growth. So if I start over here on the left, my line is forever increasing, forever going up. This is a exponential growth going this way, okay, which is what we're looking at here with our COVID-19 cases, right? Exponential. It's going up exponentially, and we're hoping to kind of level that out and flatten the curve, but it starts out here as this exponential. Okay, so our domain are all of our x values. So if we start over here, the first thing we have is arrow, so that goes to -infinity. And then we come this way. We don't have any breaks in our graph. It keeps going forever and ever. So this is going to be all real numbers forever and ever, left to right, every x value. Our range value, there is nothing down here. Remember we said it's going to get closer and closer to this x-axis, closer and closer to 0. So our range is anything bigger than 0. Y is bigger than 0. It cannot be equal to 0. Cannot be equal to 0, but it'll get bigger. Okay. All right, end behavior, we haven't talked about this in a while. As x approaches positive infinity, so as our x is, this is our x, as our x gets bigger and bigger this way, what happens to our function? This is our function. What's happening to this function line? It's going to go up forever and ever, which is what value? Positive infinity. Up, up, up. Okay. As our x value approaches negative infinity, which is to the left, negative infinity, it's going way out this way, what is happening to our function? Our function is getting closer and closer and closer to what value? Not negative infinity. Negative infinity would mean it comes way down here and it has an arrow going down this way. This is riding along this x-axis of 0. It's going to approach 0 and get closer and closer and closer to that value. Okay? All right, our y-intercept is where our line hits the y-axis, so this is 0, 1. And our asymptote is where we have a line, like a border, where our graph gets close to but never crosses. So in this case, our asymptote is here at y equals 0. Okay, and I'm going to give you a hint in just a little bit on how we find that asymptote as our graph changes and moves about. Okay. All right, so same thing on this one. Actually, time out. Let me go back here real quick. We said this was exponential growth, right? Because it gets bigger and bigger as it goes from left to right, always increasing. Okay, so our function now is 2/3 raised to the x value. So this is our b. This is our value. So is this number bigger than 1 or less than 1? 2/3. 2/3 is less than 1. So this is going to be exponential decay. It's going to be getting smaller as we go from left to right. Okay, so again, I'm going to go to Desmos. I'm going to clear out this graph and just close out on that. Okay, so this time I'm going to put 2/3 in parentheses, 2 divided by 3. I'm going to go outside of the parentheses and raise that to an x power. So my graph looks like this, exponential decay coming down and down and down, getting closer and closer again to the x-axis, or closer to that y equals 0. Okay, so I need a couple values here in my table. So I hit the settings and I looked at the table. I've got -2 at 2.25. negative 1 at 1.5, 0, 1, 1, 0.6 repeating, and 2 is at 0.4 repeating. 4. Okay, so negative 2, 2.25-ish, negative 1, positive 1.5, 0, 1, 1.6, 2.4, getting lower and lower as we come this way, and as we go back up this way, up, forever and ever. Okay, so this is our from left to right, this is our decay. It's getting lower as our x values get bigger. Okay, domain x values, every x value from left to right, arrow to arrow, all real numbers, left to right. Our range, our y values, okay, I only got y values up here above 0, so I'm going to start at 0, and we have only things bigger than 0. Do you see a pattern, how it's the same? Okay, I'll give you a hint on that in just a second. Okay, as x approaches infinity, this is our x-axis, as x approaches infinity, what's happening to our function? Our function is getting closer and closer to 0. And as our x gets closer to negative infinity, going out this way, negative infinity, look where our function's going, up through the roof, right? Positive infinity, forever and ever up, bigger, bigger, bigger. Okay, y-intercept is still at 0, 1, and our asymptote, invisible line, a wall border here at y equals 0. Okay, so here's what you're going to notice. Your answers to domain, range, y-intercept, asymptote are going to be the same for every exponential that has not been transformed. And what I mean by that, it's just this basic exponential. So some number to the x power, it will always be that same value. The only thing that's going to change those is if we put like a +5 out here at the end or something, or a -2, or we put some number in front of it. Okay, those things might change then. I'm going to let you figure that kind of out on your own, as you can use Desmos graphing tool, and you can do that part. Okay, all right, so let's talk about our transformations. Okay, as we transform our parent function, y'all, I lost my highlighters. I think one of my children took them. So don't have the highlighter. Let me see if there's one in here. Got no highlighters. Oh, I found one. Okay, I found one. Okay, so this right here is the parent function. B to the x. That's the parent function. All the rest of this are the transformations or the changes to that. Okay, so we're going to focus on the parent function first. Decide if it's exponential growth or exponential decay, depending on whether b is bigger than 1 or not. And then we'll decide what these other 3 letters do to it. Same 3 letters that we've talked about over and over again. H is going to be our horizontal shift. That's going to shift to the left and the right. Okay, so when we shift our equation, our function to the left or the right, H is either going to be plus or minus. So I think I'm looking for my answer key so I don't write the wrong thing, but I can't find it. There we go. Okay, horizontal, positive H is to the left, minus H is to the right. Remember, that's backwards from what we normally think. K is our vertical shift. That's going to move our graph up or down. Positive K moves up, minus K moves down. Okay, this is what I was telling you about your clue here for the asymptote. The asymptote is determined by this plus k out at the end. Okay, so our asymptote is always y equals k, whatever that k value is. So if it doesn't have anything out here, that's a 0, right? Plus 0. So your vertical, your asymptote would be at y equals 0. If this said plus 2, then your asymptote would be at y equals positive 2. If it said minus 6, then you'd have an asymptote at y equals negative 6. Okay? This is what determines where our asymptote is. Okay? And then the last thing is the A. The A is out in front, just like we've done before. If A is negative, we are going to reflect across the x-axis. I can spell. If A is bigger than 1, it's going to be a vertical stretch, which means it's going to make it skinnier. It's going to make it look skinnier. Okay? And if A is less than 1, it is going to be a vertical compression, which means it makes it look wider. Okay? It's going to make it look wider. This is going to make it look narrower. Okay? So we're going to start here with our parent function, and then we're going to see what happens to it from there. Okay, so we just have a couple examples to go through that. All right, so we're going to do two things. Part A, we're going to identify the parent function, and then B, we're going to describe the transformations to it. Okay. All right, so the first one is f of x equals 3 to the x power plus 5. So this right here is our parent function. So that's going to be our answer for A, 3 to the x power. That's the parent function. Okay, from there, we're going to make changes to it. So the only changes that are not highlighted is this plus 5. So what does that plus 5 do to our graph? When it's out at the back here, that's our k value. If k is plus 5, it's going to go up 5. There's nothing tagged on to the x or the exponent, and there's nothing out in front, so we're done with that. Okay? All right, second one, f of x equals 2 times 1/4 raised to the x minus 1. Okay, so our answer for A is our parent function. Our parent function is just the part with the exponent, so this and that. So maybe we'll write it as f of x because that's more technical. F of x equals 1/4 to the x power. That's our parent function. Do y'all see the word cross-section under here? I was doing geometry. That's bothering me. Okay. So what else do we now have connected to our function? I see this minus 1. Is that minus 1 h or k? Look back at your notes. Hopefully you wrote it down. This is h. So if we have a minus h, that is going to go to the right. So we're going to go to the right one. And then this 2 in the front is going to do what to our graph? Is 2, this is our a value, is that bigger than 1 or less than 1? Bigger than 1, so this is going to be a vertical stretch. Oops, stretch times 2 by a factor of 2. Vertical stretch by a factor of 2. Okay, sorry. All right, number 3, got 2 more, then we'll be done. What are we looking at? Cool, 19 minutes. All right, so what is our parent function here for number 3? Can you go ahead and write that down before I do? What is the parent function for number 3? What is connected to the exponent? 4/3 and the x. That's it. 4/3 and the x. We don't have any of the extra stuff because those are our transformations. So just the base and the exponent. That's the parent function. So from that, we're going to do a couple things to it. So let's start with this plus 2. Is this a, h, or k? This is h. So plus 2 is going to move it 2 to the left. This plus 7 at the end, that's our k value. So this was h. This is k plus 2, so that's going to go up 7. And the negative does what? Reflect over the x-axis. That's our a value. Okay? And I'm going to put one extra note in here. This value right here, this is our asymptote. Okay? Y equals 7. Okay? Let's go up here to number 2. Where is our asymptote? What do I have out here at the back? Nothing. Y equals 0. That's our asymptote. And what about number 1? My asymptote is at positive 5. Okay? No guessing on that. It just is. All right, one last one. All right. Number 4, f of x equals 1/2 times 5 raised to the x minus 4 power minus 2. So, parent function, f of x equals, what is just the number raised to the exponent? 5 to the x. 5 to the x. Okay, everything else is extra. So what does this minus 4 do? That's h. So that's going to be 4 to the right. Minus 2 out here, this is k. So that's going to be 2 down. And then this number out in front, this is a. Notice it's not negative, so we're not going to reflect it. It's going to stay up above the x-axis, but this 1/2 is going to be a vertical stretch or compress. Is this going to get wider or narrower? This is going to get wider. Vertical compression by 1/2. So everything's going to multiply by 1/2. And where is our asymptote here, just in case we wanted to graph it? Our asymptote is going to be at y equals -2, whatever that is. Okay, one last thing real quick, okay? Just in case the question said graph this or sketch a graph, find the intercept or do the domain and range, okay? I just want to show you how we would type this into our calculator, okay? All right, so I'm going to type 1/2. So I'm going to put it in as a fraction in parentheses, 1/2 like that. And then I'm going to push times, and then I'm going to do 5, and I'm going to raise 5. Now I want to raise 5 to the x minus 4, so I need to put x minus 4 in parentheses. Sorry, y'all. X minus 4 in parentheses to keep all of that together. And then minus 2. Okay? It would give me my graph. Okay, so when you type it, you want it to look just like what you got on your paper. Okay, and if you start like, because what I was doing is I didn't put the x minus 4 in parentheses, and I did 5x, and then when I did minus, it dropped it down out of the exponent, and the 4 was going out where the k is. Sorry, I know that's really awful to read. I'm sorry. There we go. So that's how I decided that that x minus 4 needs to be in parentheses for the whole exponent. Okay? Minus 2 or whatever. Alright? Cool. If you have questions about using the Desmos, about finding end behavior, any of that kind of thing, please don't hesitate to ask. Find me, text me, call me. I'd love to see your face at a Zoom meeting. I miss y'all. Okay? Love you. Bye.